Hi everyone, welcome back to online classes. Today in our class we will be discussing a very important topic for derivation, that is equations of motion. Before starting with the topic, hope you all have done your homeworks and you all have gone through the graphical representation, because we are using the graphical representation or graphical method to derive the three equations of motion here. V is equal to U plus AT, S is equal to ut plus half at square, and then v square is equal to u square plus 2as. So these are the three important equations for uniformly accelerated motion which we are going to derive today. Now, for deriving, we are going to consider the velocity time graph. You know that velocity will be along the x-axis and time will be along the y-axis. Now, we are going to consider a body moving with uniform acceleration with initial velocity u, and this is going to be the final velocity of the body v in time t, right? Now this is how the final graph it will look like. Now we are going to derive. Before starting the derivation, I request everyone to open page number 51 in your textbook. Take another book or paper with a pen and you will be deriving along with me, right? Now coming back to the derivation part, as we have told, we are going to consider a body having linear motion or uniformly accelerated motion having initial velocity u, final velocity v in a time t. Now what you have to consider is, see, when you learn about the graphical representation, main 2 points you are learning from the velocity time graph is that one is about the slope and one is about the area under the graph. So those are the two important points which we are going to use today for deriving. Now regarding the slope of a velocity time graph, it gives always acceleration. That was the first point you have already learned. And the area under a velocity time graph will always give you displacement. So these are the 2 points you have already learned. Right? Now let's start deriving. Now once again we are going to start the derivation. Get ready with your pen, paper or book, whatever it is. Open page number 51 and see figure 2.45, graph showing the linear motion with uniform acceleration. The same figure shown on the screen, you can see it in your textbook, and while I am explaining or saying about the graph, you will be going through the graph given in your textbook. Now, to derive the first equation of motion, we are going to consider the case that slope of a velocity time graph will give you acceleration, right? So, this is the point we are going to take. Now, you just come to the graph. When you see the graph, your graph is going to be line AB. Now, according to this, slope of this line AB means whatever is the velocity here divided by the time. So according to the graph, slope will be equal to, or slope gives you acceleration. Acceleration will be equal to what you will get from the graph, BE upon AE, right? Got it? Now see the graph figure carefully. Now you know what is BD. That is your final velocity V, this much, right? And ED, you know that is the initial velocity U. Now, if you know BD total and if you know ED, BE, you can find it out how. BE will be equal to BD minus DE, or you can write it as V minus U, right? Hope you got it. Now, with that condition, if you write slope is equal to A, that is acceleration, will be equal to BE by AE. Instead of BE, you can write V minus U, and instead of AE, you can write that is the total time taken T. Or from this equation, you can write V minus U is equal to AT, or arranging this equation, you will get V is equal to U plus AT. This is going to be your first equation of motion, equation number 1. Put equation number 1 for that. Now, to find out the second and third equation of motion, we are going to use the second condition which we have learned, that is area under the graph will give you the displacement S, right? So this is the condition which we are going to use to find out the second and third equation of motion. Now if you go through this graph, area under the graph means area under the line AB. So that as a whole you can find out it can be the area of trapezium OABD. So that is the total area. Now to find out the area, you can find it in two ways. That is, either you can find out the area of a trapezium using the direct equation for a trapezium, and the second method to find the area is that you can split this area into a triangle and a rectangle, find the area separately and you can add it together, you will get the total area. So these are the two ways by which you can find out the area of the given graph. Now, for finding the second equation, that is S is equal to ut plus half at square, we are going to use the direct equation for area of trapezium. And to find the third equation of motion, v square is equal to u square plus 2as, you are going to split this graph into two, that is a triangle and a rectangle, find the area separately and add it, you will get the third equation of motion. That is how we are going to do now. Now let's begin. Now to find out the second equation, as we told, we are going to consider the area under the graph, and for the second equation we are going to use the direct equation of a trapezium that you are learning in your maths. Area of a trapezium is given by half into base into sum of two parallel sides of a trapezium, right? So according to that equation, we are going to find out the area, that is area will give you the displacement S. Now area is equal to area of trapezium OABD, right? Trapezium OABD. Now let us apply the direct equation for a trapezium. Now look into the graph. According to the graph, that is area S is equal to half into, what is the base given there? OD, isn't it? Into sum of parallel sides. What are the parallel sides? OA plus BD. So this is what we are getting when we apply the direct equation of a trapezium. Now in the equation which we got, we are going to substitute for OA is equal to U, then base OD is equal to T, then sum of parallel sides OA plus BD will be equal to U plus V or V plus U. Let's see how we get the equation when we are going to substitute these values. Now according to what we have written, S will be equal to, OD will be equal to half into, OD will be is equal to T, and sum of two sides will be V plus U, right? So this is what we are going to get it. Now what we are going to do is that we are going back to the first equation. That is, from first equation of motion, V is equal to U plus AT, isn't it? Now from this equation, we are going to substitute for T, or when you consider this equation from the first equation of motion, if you write T, what will you get? T will be equal to V minus U by A, isn't it? Now for the equation which we got for displacement S, you are going to replace time T with V minus U by A. Now when you replace it, what will you get? S is equal to half. Instead of time T, you will be having V minus U by A into sum of two sides will be V plus U. This was what we got, right? Now this is of the form A plus B into A minus B. So that you can write it as half into V square minus U square by A. Got it? Yes, is equal to, this is how you will be getting. Now just rearrange this equation. What you will get? This denominator 2 you are going to take, 2a you are going to take it to the other side. You will get 2as is equal to V square minus U square. Or again when you rearrange, you will get V square is equal to U square plus 2as. This is going to be the second equation of motion. Give it equation number 2. Now derivation for second equation of motion is over. Now let's see how we are going to derive the third equation of motion. Now, as I have already told you, the third equation of motion also you are going to derive using area under the graph will give you displacement condition. Here you are going to split this area into a triangle and a rectangle. Add the areas and you are going to find out the third equation. Now let us see how we are going to derive it. As usual, slope will give you, displacement is given by the area under the graph. Here S displacement, S area, you are going to find out area of a triangle plus area of your rectangle, right? So we are going to do like this. And you already know that area of a triangle will be half into base into height, and that of a rectangle will be simply length into breadth. So with that you are going to derive it. Now accordingly S is equal to, first if you are going to consider the area of a rectangle, area of a rectangle will be given by OA into OD according to the graph. See the graph properly. Then you want to add the area of a triangle, half base into height. A base of a triangle will be BE into height will be AE. So as usual you have added. Now you want to replace it with your initial velocity, final velocity, time, whatever it is. Now let us replace it. When you are going to replace it, just see the graph carefully. That is S is equal to instead of O A, you are having initial velocity U, then OD time T. This is the area of a rectangle, plus when you come to area of a triangle, half into, instead of BE, it will be V minus U, which we have already explained how you got it as V minus U. Then again height will be AE, that is again going to be time T. So this is how you will get when you replace it. Now just you have to rearrange all these and see what you are going to get. S is equal to U into T will be UT itself, plus now second half you will be having half into V minus U into T. So this is how the final equation will look like. Now here what we are going to do is that again we are going back to the first equation, V is equal to U plus AT, and this time we are going to replace it for V minus U, or from this equation you can write V minus U is equal to AT. Now this V minus U you are going to replace it with AT. Now once you replace it, let us see what you are getting. S is equal to UT plus half AT into T, or S is equal to UT plus half AT square. Now this is nothing other than your third equation of motion, equation number 3. So these are the very important 3 equations of motion you are going to have, and for your numerical also, essay part also derivation, and these are the questions you are going to get for your numerical also. And in your numerical part, when you solve it, be very sure if a body starts from rest, U will always be 0, and if a body starts from a particular velocity and comes to rest after some time, V will be equal to 0. So these are the conditions you have to remember when you are going to solve with your numericals also. And your numerical of the chapter B part, that is 2B and 2C, together it will be uploaded. And before that, if you are having any doubt regarding your numericals, just go through that and will be discussed when the school reopens. Now coming to your homework part, you can solve your question answers of exercise 2C in your copy. Solve your exercise 2C in your copy. With this, we are winding up today.